We'll proceed in the parameterization in the vector, and we will see kind of how we can calculate the distance as far as if we have a vector parameterization equation. So that we'll see, then we'll see some examples, and if time permits, then we will enter into much awaited vector field, highly important. Okay, now we have calculated the velocity, we have calculated acceleration. So idea is, if I have a curve, then velocity, that now it's a vector. If it is a vector, then I cannot say that it is the velocity. So velocity vector has a direction. So if I have a kind of okay, so if I have a kind of a circle, circle is a curve. Circle is not a straight line. So if I have a circle, then if I am sitting at the parameter, and if I see the vector that is from origin to any point in the arc, okay, circular arc from center, if I see any point, then vector would be kind of radial through radius. So that is the equation of the, that is the direction of the vector. But we saw that at any point in the circle, if this is the center, and any point in the circle, if this is the radial vector, then tangent is the velocity. And then again, if this is radial vector, position vector, then acceleration is along the position vector only, but the direction would be reverse. So direction of the acceleration would be exactly in the same direction as the position vector, but it will be reverse. So if position vector is from center, it is going outwards, then acceleration, it is in same direction, but it is coming inwards. That is one thing. Second thing is the velocity is tangent. Okay, so this is what we have seen. So calculating velocity vector, calculating acceleration vector. So if it is arc, then velocity vector is perpendicular to the radial vector, whereas acceleration vector is perpendicular to the velocity vector, but it is in direction of radial vector, just opposite 180. So this is what we have seen. Now can we calculate the kind of length of the, so this is arc equation. If it is arc, then velocity, acceleration, they are perpendicular to each other. But if it is a straight line, if it is a straight line, if it is a kind of the parametric vector r, if r is a vector, then r on top of it I place arrow. R on top of it I place arrow. Then it becomes an array. It becomes a vector. In the bracket or in bracket, if I put, then it becomes a parametric vector. Parametric vector because it receives t as parameter. It behaves like a vector, which a kind of a function. Function in the sense that it is now vector is not a static, it is variable. So inside the vector there are t's, t, and if it is rt, then there are t, and as per the t, whatever value we put in the t, then rt keeps changing. So that is the a kind of parametric vector. Now, if I have a parametric vector, like if I see this circle, then I have parametric. Suppose there is it is an ellipse, then 2 cos t I plus sine t, 2 cos t I plus sine t j. If this is xy plane, if this is xy plane, if I rotate this like this, then this is new xy plane. If this is xy plane, then if I say that 2 cos t I, so in the I direction, x direction, the parametric vector has kind of component. The x component is 2 cos t, whereas the y component is sin t. If both are not same, one place the radius is 2, I mean square root radius is 2, whereas other place radius is 1. 2 cos ti plus sin t j. If that is the case, then it is typical equation of a ellipse where, oops, where it is typical case of a ellipse. If this is ellipse, then along x direction the radius is 2, whereas along I believe it is a kind of square root 2, a square a cos theta plus b sin theta equal to r square. I believe this is the equation, or a square cos theta plus b square sin theta equal to r square. It is one of them, the equation of the ellipse, whatever. So it is elliptical because the radius that is constitute in the x direction and y direction, they are not same. So r cos ti plus sin tj. Okay, if this is the kind of x component and y component, then this is equation of ellipse. So r vector, parametric vector of t equal to 2 cos ti plus sin tj. X component is 2 cos t and y component is sin t. If that is the case, then it is equation of an ellipse. If it is ellipse, then what is the parameter of ellipse? Okay, so these are the kind of, we can say that these are the uh, luxury, these are the inbuilt luxury we are getting in vector. That much is not possible in in kind of algebraic calculus. So algebra would not give this much. So this much is kind of possible only in vector calculus. I would say algebraic vector calculus or parametric vector calculus. Now, it is 2 cos t is the x component and sin t is y component. Now, I have to calculate the parameter, means I have to calculate the length of the parametric vector. What is the length of the parametric vector or arc? That is the question. Either it is ellipse, this is a circle, this is a kind of a polygon, or any shape. What is the length of the arc? Okay, so or what is the length of the curve, rather, that is the better one. So that is the query. Okay, now we know that if it is a curve, then velocity is perpendicular and acceleration is again direction, the position vector opposite. But if it is a line, then velocity is in direction of the position vector and acceleration is also in direction of the position vector. So if a person is walking and he is walking, so it has velocity. Now he is accelerating and he is walking in a straight line. If he is walking in a straight line, then the velocity, if I from the position vector, if I calculate the velocity vector, then direction would be same as position vector. Acceleration would be same as the position vector. But if he is walking in a curve, then at any moment the acceleration velocity would be the tangent to the curve where we are calculating, and then acceleration would be in same direction the position vector that we see there, but it will be in reverse direction. So that is what we have seen. Now equation of the parametric vector is 2 cos t, that is x component, 2 cos t I plus sin tj, that is the y component sin t. If this is an ellipse, then what is the kind of perimeter of the ellipse? That is the question. If I know velocity, if I know rate of change of distance per unit time, then if I integrate that, then I get the distance. This is integration. If I have rate of change of something per unit time, then rate of change of something, the something we can calculate. Rate of change of collection, if I know, means how much collection happens per unit time. If I integrate over time, I get the net collection. Rate of change in something, okay, that is per unit something else, then something I can calculate when I integrate with the something else. Okay, that is the integration. So if I want to calculate the distance, then if I have distance per second or distance per angle per radian, then if I integrate through the radian, I get the distance. But I have distance equation, not the distance per radian. So I have 2 cos t, that is the distance equation. Sin t, that is the y component, that is the distance equation. If both are distance equations, but I want to calculate the net distance when it is a ellipse, so full 2 pi radian. Anytime if I put value, if I put t equal to 0, then it will be 2. T equal to 0, then it will be 2. So along the x-axis, the length will be 2. If I put t as pi by 2, then 2 cos t is 0, whereas it is 1. So along x-axis, it is 1. Okay. So, so it is rotating like this and then becoming smaller, 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 and then it is becoming big and then smaller, smaller. So this is ellipse. If now, so I can find the position at any moment if I have t cos t, sin t, x component, y component. Probably this much explanation you won't get anywhere else. But anyway, now I have t cos t and sin t. If that is the case, and if I need to find a distance, then I have to find d distance by d time. That is the rate of change in the distance per unit time that is required. And if I integrate with the time, I get the next distance. So 2 cos t, if I integrate, if I differentiate, then it becomes velocity. Sin t, if I differentiate, it becomes velocity. So it will become minus 2 sin t, that is the x component of velocity, and cos t, that is the y component of velocity. Okay, now I have the velocity. Minus 2. 2 cos t is the position vector or displacement. 2 cos t is the x component and sin t is the y component. Now, if I differentiate it, it becomes minus 2 sin t, and that side it will become cos t. So, x component of the velocity is minus 2 sin t and y component of the velocity is cos t. Now, what is the if it is a velocity vector? So velocity vector is minus 2 sin t I plus cos t j. That is the velocity vector. That is r dot dash or dr by dt. This is a velocity vector. Now, if I have velocity vector, then I can calculate the distance because it is rate of change in the distance per unit time. If that is the case, then I can integrate and I can calculate the distance. Okay. Now, what is the any vector has direction and magnitude? If I have velocity vector, then it has a direction, that is minus 2 sin t as x and cos t as sine. If I keep changing the t as radian angle, I would get velocity vector direction. So at t equal to 0, it comes as minus 2 sin t, that is 0. Whereas the x component at t equal to 0 is nothing, whereas the y component is 1. So if this is x-axis of the ellipse and this is y-axis of the ellipse, when we saw that the position vector x at t equal to 0 was 2 cos t, that was 2, whereas the velocity x component is 0. whereas y component is 1. So velocity vector is in this direction when at t equal to 0. So this is perpendicular to the position vector. If this is the position vector, then velocity vector is perpendicular to it, it's a tangent. Now what is the magnitude of the velocity vector? So if it is minus 2 sine t x component and cos t as y component, then x component square plus y component square root, that is the magnitude. So it will become minus 2 sine t, then it will become 4 sine square t, 4 sine square t plus cos square t, 4 sine square t plus cos square t square root dt, and now this is the magnitude of the velocity at any time t. Now integrate with the 0 and 2 pi. You get the you get the parameter of ellipse. Now go and integrate. Okay, so 4 sine square t plus cos square t square root, that is the magnitude of the velocity vector at any time t, and then we integrate with the dt. So now we have the displacement per unit time integrating with the time, then it will give us the distance. Integrate the time is 0 to 2. I mean t is the angle, not the time. So at t equal to 0 and t equal to 2 pi, that is the limit. So 4 sine square t plus cos square t square root dt, integrate dt angle from 0 to 2 pi. Whatever you get, that is the kind of circumference of ellipse. Okay. Now let's try a circle. Now it is easy. So it is a 2 square. Now 2 cos t plus sin t would go away. Cos t plus sin t. Simple. If this is a circle, then r cos t, r sin t. Suppose the radius is 1. If radius is 1, then r cos t plus sin t. Now the velocity vector will become minus sin t I plus cos t j. Then velocity vectors, the magnitude will become sin square t plus cos square t square root. So that is 1. So 1 dt. 1 dt means t. T is the integration. If t is the integration, then 0 to 2 pi is 2 pi. So 2 pi is a perimeter. If 2 pi is the perimeter, now let's the radius is r. Then r cos t I plus r sin t j is the equation of the position vector of a, or equation of the parametric position vector of a circle. R cos t I plus r sin t j. If that is the case, then the velocity vector is minus r sin t I plus r cos t j. If that is the true, then that the magnitude of the velocity vector is r square sin square t plus r square cos square t square root. That will become r, and then in r will come out, r square root r would come out, and then it is square root of sine square t plus cos square t, that will come as 1. Now we have to integrate r square with dt, then it will come as r square t. Now if I place the limit, the angle t is the angle from 0 to 2 pi, then it will become r into 2 pi r. So 2 pi r is the perimeter of a circle. Whereas what we saw, that if it is a 2 cos t I plus sin t j is the equation of an ellipse, then it came as kind of 4 sin square t plus cos square t square root dt 0 to 2 pi. Now go and integrate and then place the 0 to 2 pi against the t. So this is kind of equation, or this is the parameter of ellipse. So any curve, if I need to find the parameter, then I need to calculate the velocity and then magnitude of the velocity and then integrate it with the angle or whatever is the variable t you have taken. That's it. So this is a kind of a genius concept. So what is a kind of vector calculus? Vector calculus where we have kind of a vector equation in terms of independent variable t. So x component, y component and z component. So x component now we can call it ft, function over t. Y component, so any vector has three components if it is three dimensional. Xi plus Yj plus Zk. So here x component is a kind of function over t. So Ft, Gt and Ht. So Ht is function over t, that is a Z component, and Gt is the Y component, Ft is the X component. Now, if I want to calculate the velocity, then dx by dt, dy by dt, and dz by dt, and these would be three components of the velocity vector. If I have dx by dt, then d2 square x by dt square, d2 square y by dt square, and d2 square z by dt square are the x, y, z component of the acceleration vector. What is the acceleration? If I have this vector, then what is the acceleration at any t? d2 square x by dt square whole square plus dt square y by dt square whole square plus d square z by dt square whole square root. What is the magnitude of vector xi plus yj plus zk? X square plus y square plus z square root. Same thing hold true everywhere. So if I have now with the parametric where we have rt, earlier we had vector on arrow on top of r. Now we have rt function over t and then vector. Then that is fti plus gtk and ht, gtj and htk. If that is true, then direction of the vector is, if I replace t with the variable that is representing, then whatever comes, and if I draw the position vector, that is the direction. What is the magnitude? F square t plus g square t plus h square t square. So this holds true for position vector and velocity vector, acceleration vector. Only thing, if I replace t with some value, that equation will get x value, y value and z value. If I draw the position vector, then it gives us the direction. Okay, now suppose I have another case. I have a case where the two vectors, okay, I have another case where I have two vectors, vector, one vector and second vector. Now these two vectors, these are parametric vectors. So equation of first vector can be considered like 1i plus 2j plus 3k plus 2ti plus 3tj plus 4tk. So 2ti plus 3tj plus 4tk, 2ti plus 3tj plus 4tk is the actual vector. Okay, that is the actual position vector. Whereas I plus suppose I am kind of restating the equation. I plus j plus 2k, I plus j plus 2k plus 2ti plus 3tj plus 4tk, or this can be stated as I plus j plus 2k plus t and in braces 2i plus 3j plus 4k. So 2ti plus 3tj plus 4tk is the actual equation of the vector, whereas the first vector I plus j plus 2k is considered as a kind of as a point that is that will come as 112. I plus j plus 2k is 112. So that is the point through which the vector passes through. So the actual vector equation is position vector of the equation of the actual parametric vector is 2ti plus 3tj plus 4tk. If this vector passes through a point that is 112, then equation of the full equation of the parametric becomes I plus j plus 2k plus 2ti plus 3tj plus 4tk. If I have two vectors, okay, I have two vectors, that is r1t and r2t. If these two vectors are in space, can I say that they hit each other? If they hit each other, means if this equation is in variation of time, where t is time, then at same time they will have same position. Then they hit each other. Now, if I have a vector like I showed, I plus j plus 2k plus 2ti plus 3tj plus 40k, then I have another vector in this form only. Then x component we have to equate, y component we have to equate, and z component we have to equate. Now we have to calculate the t against each other. So if I equate x equation of two vectors, one is 1 plus 2t. Suppose other is 4t, then 1 plus 2t equal to 4t. Then it will become 1 equal to 2t. So t equal to half. When time is half second or half unit, then x component would meet each other. So vector is, that is the issue. X component separate, y component separate, z component separate. Similar fashion, y component we have to equate and find out the t value where y component they clash each other. And z component separately we have to equate and see the t value where they clash each other. But if the vector they really clash each other, then t at which x component and y component and z component they hit each other, their t should be same everywhere. If it is same, then their two vector parametric vector they actually hit each other. Okay, now suppose that we are not finding the consistent t among the x, y, z component, then what is the scenario that they cross each other? One passed and it created a path. In that path, x also passed, but they did not hit each other. If that is the case, then at any point both vectors were same, but time was not same. One passed through that point in t1 time, when time was t1. Another passed through that point when time was t2. Then they cross each other. They do not hit each other, but they cross each other. Now, the x component of the first vector where t we had put, that is t1, and x component of other vector, that is t2. Now, I have 1 plus 2t1 equal to 4t2. Similarly, y component of the first is t1, y component in second one is t2. Now we have two independent variables t1 and t2, and we have two equations. We can find the value of t1 and t2. If we can find the value of t1 and t2, two independent variables with two equations, then this t1 and t2 we will put in z components of first vector and second vector. If they are equal, this proves that they crossed each other. So parametric vector is an area of research. Since we have x component, y component and z component separately, either it can be cumbersome, weird for some people, but for some people it opens door to kind of further enhancement, modification, or altogether bringing in the new things. Okay, so this is the idea. Now we'll go back and we'll have one more example. Like I have a equation of the parametric equation is like it is kind of it is we can say I plus 2j, I plus 2j plus 3t plus 3ti plus 4tk. This is equation of a parametric vector. I plus 2j, one vector, plus t in the braces 3i plus 3i plus 4j. I plus 2j, one vector, plus t and in braces 3i plus 4j. If that is the equation of vector, then what is the equation of the algebraic line? So just I have placed it so that we can have more practice. Now what is the vector now? I plus 2j plus 3ti plus 4tj. Then this proves that actual vector is 3ti plus 4tj and it passes through a point 1 comma 2. So 3i 3ti plus 4tj is a vector. So at t equal to 0, it is 1 comma 2. So that is the beginning point rather than origin. And at t equal to 1, then it is 3i and 1 here. So 4i plus 6j. So 4 and 6 wherever it comes, that line, okay, 4 and 6 and 1 and 2, whatever is the line, that is the kind of its displacement vector. So if time equal to 1, if time equal to 1, then a vector has one end, that is 1 comma 2, and other end is 4 comma 6. If I want to get the position vector, then it will be, I have to kind of subtract it to get the position vector. So if I want the position vector of it, okay, then 4 minus 1, that is 3, 6 minus 2, that is 4. So same thing what we are saying, 3ti plus 4tj. Now if I want this equation to be in kind of in algebraic fashion, I plus 2j plus 3ti plus 4tj, then the equation of the vector is 3ti plus 4tj. This explanation would not be available in any of the book. That I mean, whatever we are talking, this way of explanation is not available anywhere. You can go and you can search. Anyway, so I plus 2j plus 3ti plus 4tj, if this is the equation of vector, the actual vector is 3ti plus 4tj. If that is the case, then the equation of the line in algebra is y equal to mx. Y equal to dy by dx, that is m slope, y equal to mx. If that is the case, then y equal to m, that is dy by dx. So if there is 3 variation in x, 3ti, then 4 variation in y, 4tj. So m is 4 by 3 dy by dx per unit change in x. If it is 3 unit change, then 4 unit change in y. dy by dx, that is 4 by 3. So y equal to 4 by 3x is the equation of line. If it is passing through point 1 comma t 2, then y minus y0 equal to m x minus x0. That is new equation. Means the origin is the line what we had drawn earlier that passes through origin. Now I have to shift it to 1 comma 2. So y minus y0 equal to m x minus x0. So y minus 2 equal to 4 by 3 x minus 1, that is 4 by 3 x minus 4 by 3. So y minus 2 equal to 4 by 3 x minus 4 by 3. So y equal to 4 by 3 x minus 4 by 3 plus 2, that will come as y equal to 4 by 3 x plus 2 by 3 minus 4 by 3 plus 2, then 6 minus 4, 2 by 3. So equation of the line is y equal to 4 by 3x plus 2 by 3. So if I have a parametric vector, and parametric vector has a kind of equation 2i plus 3i plus 2j plus 3ti plus 4tj, then equation is the algebraic form is y equal to 4 by 3x plus 2 by 3. Both are completely different. Or I can say that 4x minus 3y plus 2 equal to 0, or 4x minus 3y equal to minus 2. So that is, but just see, 4x minus 3y equal to minus 2. This is the algebraic equation. And there I plus 2j plus 3ti plus 4tj, both are completely different representation. So algebraic representation is based upon the slope, whereas the vector equation is based upon the position vector, origin and next vector, and where it is passing through. But if you go in the code, then all three components of the vector is like a separate vector coming in x direction, y direction, and z direction, and they combine together and go. So if I say I plus 2j plus 3ti plus 4tj, then a vector is coming in along the x direction and its vector is 1 plus 2 plus 3t, and another vector that is going in y direction is 2 plus 4t. If they combine together, they form 1 plus 2ti, 1 plus 3ti, and 2 plus 4tj. So this is vector is completely representation is completely based upon the vector components basically, whereas algebraic equation is based upon the slope, independent component, dependent component. Here the components. So now in the parametric vector equation, the components we have put as a function of t. X component is a function of t, y component is function of t, and z component is function of t. So this is separate to normal vector equation. Okay, so we are kind of done with the parametric equation, and now we would enter into vector field. Whatever we are stating again in the vector field, it is not mentioned anywhere. So what is a vector field? Vector field, okay, if I can specify the equation of a parametric function, parametric vector in the function of t, then still I can specify the vector in function of x, y, z. No one can stop us. So can I say that my vector equation is xi plus xj plus x into y into z zk. The x component, if I have a vector, if I have a position vector means a vector that is passing from origin to a point that is x, y, z. So if I say I have a position vector f, just say f x comma y comma z. If I have a point x comma y comma z, then I have a vector f. Then equation is xi plus xj plus x into y into z k. Then at any point x comma y comma z, if I have uh, I have a xyz plane, and I have an origin, and I have a point xyz, then actual the component of the vector, I mean I should restate this. Okay, now if just suppose, so if I say that I have an origin is 0 comma 0 comma 0, origin is 0 comma 0 comma 0, and I have a point called x, y, and z, then the position vector is x minus 0, y minus 0, z minus 0, that is xi plus yj plus zk. I have a point origin 0 comma 0 comma 0, and I have a point that is x comma xyz. So points x factor is x, point y factor is also x, and point z factor is x into y into z. Okay, if that is the case, then this is not a simple vector. If I say that I have a point that is in function of t, this is what we saw in parametric equation. Like if I have a circle cos ti plus sin tj, this is a kind of a vector field. In a sense, if I keep changing t, then I keep changing the points. Okay, so whatever origin is same 0 comma 0, but the points on the curve is dependent upon the independent variable t, where x component is function over t, y component is function over t. Now here again I have equation, vector is not in a static form, vector is form of function. So if vector is in form of function, then at any point x component is x, y component is x, and z component is x into y into z. Again, this is a function over the position vector. the position vector is xyz, xi plus yi plus zk, if that is the position vector, then function over position vector is xi plus xj plus x into y into zk. If that is true, then at each value of x, we get separate vectors. All right, right? So if I have x-axis, if I have y-axis, and if I have z-axis, then at any x, at any y, at any z, okay, so x is 2, y is 3, and z is 4. Now, if I substitute this function, this equation, that equation is xi plus xj plus xyzk, then the position vector would be x is 2 and y is 3 and z is 4. So 2 into 3 into 4. So 2i plus 2i plus 24k. So the vector position is changing as per the x value. I believe it is now more clear. So if I have x-axis, if I have y-axis, and if I have z-axis, if I take x, that is variable, any x, 1, 2, 3, 4, 5, 6, 1.1, 1.2, 5.8, any y and any z, depending upon the x, the vector point is changing. If x is 1, y is 1, and z is 1, the point that I am taking now is 1i plus 1j plus 1k. So it is actually 1, 1, 1, 1 because xi plus yj plus xyz k. If I take it as 1, 1 and 2, then 1 x component is 1, y component is 1, where z component is 2. So if I take z component is 2, so it is again same. Now if I take 1, 2, 3, x is 1, y is 2, where is z is 3, then xi plus xj plus x into y into zk, if this is the function that creates a vector. So vector field is nothing but vector factory. A factory where the independent component is xyz, depending upon the xyz value, it generates separate vectors. So the kind of, we talked about the parametric vector, they are also factory where independent component is only t. Based upon the t, it generates different vectors. Here, the independent variable is xyz. Based upon the xyz, it generates different vector. So based upon the xyz value, the vectors x, y, and z components are different. So x, y, z component of a vector that we get, that is function over x, y, z only. It is quite complex and it is not in a general use. But where it has limitation and how we can get rid of the limitation, that we will see. So now if I have a value, okay, now I have a point that is 1, 2, and 3, and the function or factory which generate the vector or vector field, that is xi plus yj plus xyzk, then the x component is 1, y component is 1, whereas z component is 3 into 2, 6. So x converted to 1. Okay, the point we are taking is 1, 2, 3. The vector what we'll get, okay, is x component is 1, y component is again 1 because it is xi plus xj, whereas z component is 6. So the actual y component is 2, that converted to 1, and z component is 3 but it converted to 6. Now if I have a kind of a position vector, that is r r x y z. So if there is x y z, then position vector is xi plus yj plus zk. So if there is a point that is 1, 2, 3, then its position vector is I plus 2j plus 3k. But if I place one function over it, function over position vector. In Python, I have a function which takes three coordinates x, y, z, and it returns different vector. This is vector field. Means if I have a position vector, inside that if I pass xyz, it immediately converts to xi plus yj plus 4k vector. But I have a function over this position vector which takes the xyz and do some computation and returns different vector, in the sense different x, y and z component. This is vector field, and this explanation is not available anywhere. So if I have a function, okay, now if I have function over position vector, the vector field is xi plus xj plus xyzk, and if I pass 1, 2 and 3, then x component is 1, y component is 1, 2 got modified to 1, and z component was 3, it becomes 6. So modifying the position vector to a new vector, that is the vector field. Amazing, mind blowing. Okay, but later we'll see that it is cumbersome. This is what we keep on saying, that in vector anyway we have x component, y component, z component, and then keeping x as a function of xyz and keeping y as a function of xyz and keeping z as a function of xyz, and then substituting value and calculating it, so it becomes a mess. That's why the idea was to have one independent component t, so that x would be ft, gt and ht, that is the z component. But anyway, no one stops us keeping the independent variable xyz as far as xyz component of the net vector. Then it will be a function over the position vector, and that function, if I pass xyz, it returns new xyz. What is the importance of this function, where it comes into the picture? So still we have everything in algebra. So still the calculus is in algebra. So from calculus, now we know that how we can have altogether algebraic vector. But that we have to start from the beginning. Then only we have, earlier we have RT, that is a vector, R, that is a vector. Now we have RT, function over T. But algebraic equation are still in function of XYZ. So algebraic equation to the parametric t variable equation, how we can transfer. So there directly we cannot make it t. So first we will have vector field and slowly we will convert it to the parametric vector. It is an interesting story. But problem is the machine learning, artificial intelligence. The way artificial intelligence brings the number of components, orthogonal components or features, and that becomes hectic. So that's why we are running here and there, because the need is now enormous. We need a data set where the kind of axis like x, y, z axis, the axis, that is features, are too many. Now visualizing is difficult, managing it is difficult. That's why calculus become similar to multiple variable calculus. So things from multiple variable calculus, we saw that we started with kind of partial derivative, chain rule, orthogonal components. Now we entered into parametric vector. I hope now we entered into vector field, that is the algebraic equation. Now how we'll see it will make it to the parametric vector. But anyway, we have kind of initiated, we made a beginning in the vector field. So we will see the kind of study more on it. So that we'll see.